All right, now we're going to start looking at different ways of using the quadratic formula to analyze not just what do the functions tell us about the graphs, but how to find the graphs from those functions. And we have to use both ways, the complete the square as well as the quadratic formula, and how to interpret these things. So in section 3, it's analyzing the graphs of quadratic functions. When we analyze the graphs, now one I'm going to call those QEs. To analyze the graphs of the quadratic equations, you need to know one, the direction of the graph. In other words, does it open up or down? The x-intercepts or solutions. We can have two of them. We can have one of them, or we can have no intercepts. The y-intercept, you have to have a y-intercept. It has to cross the y-axis somewhere. We have to know the vertex. Highest or lowest point. Those are the vertex. And we have to know the axis of symmetry. All quadratic equations, the graphs of them, because the graphs are parabolas, they're symmetric. They're symmetric about the vertex. They're mirror image around the vertex. So these are the 5 things we have to know. And of course, to make it a nicer graph, you have to know a couple of extra points other than those. But because of the concept of symmetry, once you find one point, you know there's always automatically a mirror point on the other side. So at any point you find, you double the value of how many points you're going to graph. So We have two forms of quadratic equations. We call this the vertex form. And then we have the standard form. So far, so good. How do we know these are quadratic equations? Yeah, because of the degrees, because the largest degree is 2. That's what tells us they're quadratic equations. Now, once we know they're quadratic equations, we only have to determine, does it open up or down? The degree tells us that they are quadratic equations. Remember, degree equals the exponent. Since we know the type of equation, it is we know the shape of the graph. We know the shape and direction of the graph. It opens up if A is positive. Opens down if A is negative. So this A tells us the direction. If, okay, well, The leading term. The term with the largest exponent. That's the leading term. So the leading term is made up of these two parts. A is called the leading coefficient. And the 2 is called the degree. That's the leading term is the A part. This is the one with the A in it. So just by looking at the equation, you can tell me the shape of it. Is it going to be a parabola? Is it going to be a cube or whatever? And you can tell me the direction. Since it's quadratic, and if A, the leading coefficient, the number in front, if it's positive, it's going to open up. If it's negative, it opens down. Here's some examples. Plus 3 squared minus 2. This is A. This is B. G of x equals negative 2x minus 1 squared plus 3. So looking at these 4 examples, what can you tell me the graph's going to look like for all these? What out of all these, what can you tell me about them? A and C is up. Okay. Why do we know that?
Because that 2 is positive.
Right, because the leading coefficient is positive. And so these are going to look like what?
Down.
These are going to go down. And we know they're quadratic because it's squared. All right, what else can you tell me about them?
They're gonna have at least 2 solutions. Oh,
Well, yeah, that goes for quadratic equations. Yes. These 2 here, you can tell me the y-intercepts.
it's gonna be
This one's going to be at 16, so this graph is going to look something like this. 16. It could look like this. This one's going to have y-intercept at 1. Just by looking at it, we know the shape, the direction, and 1 point at least. Can you tell me the vertex?
um, it's gotta, it's gonna be the
No. To find the vertex, it's easier than thought. It's just that easy as just like making it up. Remember, we have two types of equations. More examples here. Now, the reason this is called, the first one's called the vertex form, because the vertex is the point HK. It's just there. The vertex is just the point HK. Now, remember, when we, in chapter 1, if it's ever inside the parenthesis, it's always the opposite of what's inside there. So if that's a minus H, the answer is H. If it's a plus H, it's negative H. So for example, these top two, what are my vertices? Where's my vertex in the top one?
Oh, no, I'm sorry, 2. Would it be -2?
Yeah, it is what it is on that side.
I'm sorry.
So it's at -3, -2. So the vertex of the other one is where?
Positive? And positive?
Mhm. Okay, so if it's in vertex form, it's super easy. Just look at the inside parenthesis in there. If it's in standard form, we've actually found the vertex before with 2 parts. Remember this formula? Remember that formula? What's it called? Gets, yeah, I know. Get some different color highlighters so you can highlight the examples and definitions and stuff. I know that's just see yours right there. It's the quadratic formula. So that finds me the x-intercepts. But if we take the discriminant, this thing here, if we get rid of it, if we make it equal to 0, then we have x is equal to -b over 2a. So the vertex is going to be the x value will be at -b over 2a. Once we find that, we plug it back into the equation, and that gives us the y value. So the x value is this -b over 2a. That's the quadratic formula. That's the first part of it. Whatever that is, plug that inside our equation, and that tells me the y value. We're going to do some examples, so don't let it worry about you. But these are the two methods of finding the vertices. Also, the x value of the vertex. Remember, since the graph, let's say it looks like this. If this is my vertex, what that means, that's the lowest point. It has to be equal on both sides. So the x value of the vertex is called the axis of symmetry. So the x value of the vertex is the axis of symmetry. So the axis of symmetry is our h value. The axis of symmetry is negative b over 2a, depending on how it's given to you. Because from that moment on, everything you do on the right-hand side is exactly the same across that line. So in this one, what is my axis of symmetry? This one here. Is the line x equals -3. At -3, that's my axis of symmetry. So my graph will look something like this. The axis of symmetry of this one is the line x equals +1. It's a vertical line, x equals. What's the vertex for this one? Well, these next two, let's go ahead and do it on another page. I have more room. So we have f of x equals 2x plus 12x plus 16, and g of x is equal to -2x plus 4 minus 1 plus 1. So the vertex. Remember, if it's in standard form, we have to use this formula. So for right now, what are my A, B, and C in this first one? What's my A, B, and C? Yeah. Yes. Very good. Excellent. So my x value of my vertex is at -b over 2a.
So it would be -12
Over.
2 times 3.
So -12 over 4 is equal to -3. So x is equal to -3. This is also my axis of symmetry. So I have -3. According to this formula I have, my x value is -3. So now I got to plug that -3 back inside the equation. to find my y value. So f of -3 is equal to 2 times -3 squared plus 12 times -3 plus 16. We'll work that out. -3 squared is +9. Negative times positive is negative. 12 times 3 is 36. And 18 minus 36. So I can combine 18 plus 16 is 34 minus 36. Since 36 is bigger, it's negative. 36 minus 34 is -2. So my vertex is at -3, -2. And the axis of symmetry is on the line x equals -3.
So they're the same thing, A and B. I mean, A and C.
Yeah, I just expanded them. In my head. How about, okay, go ahead and do this one. Work that one out real quick. Find me the vertex. Okay, so the vertex is the same thing. So it's -b over 2a. And we have to put it back inside there, -b over 2a. So we have to label A, B, and C. A is -2, B is, and C, perfect. So my x value, which is -b over 2a, is -4 over 2 times -2. So it's -4 over -4 is +1. So that's also my axis of symmetry. So B is equal to 1 G of 1. So that means I got to plug it back into my original equation. Got -2 times 1 plus 4 times 1 plus 1. 1 squared is 1 times -2 is, well, I'll do this piece by piece. So negative times positive is negative. 2 times 1 is 2. They're both positive. 4 times 1 is 4. -2 plus 4 is 2, plus 1 is 3. So my vertex is 1, 3. And the axis of symmetry is x equals 1. Pretty straightforward. Okay, so what we just labored to do, so we have -3, -2, 1. -3, -2. The vertex is 1, 3. The axis of symmetry is x equals -3. axis of symmetry, x equals 1. So far, so good? So with these, depending on the type of equation you have, finding the vertex, if you're in the vertex form, it's easy. Just look at it. If it's in standard form, you have to work it out. It switches. How about the y-intercept? The y-intercept for C is what? Yeah. It happens at 16. So it's 0, comma 16. Right. On D, what's my y-intercept? 0, comma 1. Yeah. So finding the y-intercept is on the standard form is easy. But to find the y-intercept in vertex form, we can't just look at a number. To find the y-intercept, in standard form, the y-intercept is at the location 0, comma C. It's whatever the constant is. If it's in vertex form, the y-intercept is a process. Set x equal to 0. And then solve. So let's look at A and B here. So we notice these are in what form? What form are these in? Vertex form. I want to find the y-intercept. So remember, f of x is the same thing as y. So I set x equal to 0. And I work it out. 0 plus 3 is 3. 3 squared is 9. 2 times 9 is 18. 18 minus 2 is 16. So my y-intercept is at 0, 16. So it's a trade-off. It's a trade-off on which one's easier to use for what. So find me the y-intercept of the next equation. Okay, so again, the g of x is the same thing as the y. So the first thing you have to do is set x equal to 0. Work inside the parenthesis. 0 minus 1 is -1 squared. Order of operations, -1 squared is +1. Negative times positive is negative. 2 times 1 is 2. -2 plus 3 is +1. So my y-intercept is at 0, 1. Pretty easy. So you see, we have the x-intercept. We can find the x-intercept by using the quadratic formula. We can find the vertex. We can find the y-intercept. We know the shape and direction. Graphing is easy. Let's look at this. Let's look at these examples now. F of x equals x squared plus 10x plus 23. Find the vertex, the axis of symmetry, the y-intercept, the x-intercept. Yeah, that should be enough. And then let's graph it. Okay, can we do any of these without doing any work? Just by looking at it, what can we tell me? The y-intercept, which is going to be what? 0, 23. Excellent. So at 0, 23, we have a y-intercept. The next easiest thing to do is find the axis of symmetry. So the axis of symmetry is, how do we find that? Is the equation x equals -b over 2a. So what are a, b, and c here? A is, b is, and c. So we have -10 over 2 times 1 makes it -10 over 2 makes it -5. So the axis of symmetry is the line x equals -5. We can use that to find the vertex also. So the x value of your vertex is the axis of symmetry. So we know the axis of symmetry is right here. Where's the y value? So I put the 5 inside the function. So 5 squared is 25. 10 times 5 is 50, plus 23. Well, that's more than, it's 108. No. 103. Oh, it's 98. 98. Everybody okay with that? So let's look at our picture. This one's gonna look pretty weird. Did I copy it down correctly? Yeah. Because at 5, I'm sorry, it's -5. That's my bad. It's -50. So we have 48 minus 50 is -2. You guys didn't stop me there.
I looked at it, I thought she was right.
No, no, there's the extra there.
When it went from -5 to 5, I looked at it twice, I was like.
Where did he get that from?
I was like,
What is he smoking? Yeah, so at -2, so we have a vertex at 5, -2. There's our vertex. Which means that we are going to have 2 x-intercepts. So we found the vertex. We know the vertex is at -5, -2. The axis of symmetry is at x equals -5. How do we find our, bless you, how do we find our x-intercepts? Use the quadratic formula. That finds the x-intercepts. And we already labeled A, B, and C as 1, 10, 23. So we have -10 plus or minus 10 squared, 4 times 1 times 23 over 2 times 1. -10 plus or minus 100 minus 92 -10 plus or minus square root of 8 over 2. Everybody follow me so far? Eight. 8 is made up of 2 times 2 times 2 times 2. So the square root of 8 becomes 2 square root of 2. Since I can take out, if there's a pair, I can take it out. So it's 2 square root of 2. On top, I can take out a 2, which will give me -5 plus or minus square root of 2 over 2. The 2's cancel, so my x-intercepts are at these 2 points. Those are my x-intercepts. I always shows nicer numbers, but this shows us how it's supposed to be done. So let's look at this. If we notice it's -5 plus or minus square root of 2, our graph, remember the axis of symmetry is at -5. So this first one is -5 minus square root of 2. And the other side is -5 plus square root of 2. Because it's symmetric, wherever this one crosses, the same distance on the other side has to be the other one. Oops, hold. This is plus and that one's minus. Can we find another point? With what will we have here? Can we find another point of our graph?
Oh, can we find another one on that one?
Yes, without doing any math. We have a vertex here, or we have a point here, it's matched there, right? We have a point here that's from the axis of symmetry, it's 5 units this way and 23 up. So I can go the other way. I can go 5 units this way, which makes it -10, and go up 23. Because it's symmetric. I wish it was a nicer equation. Sorry, everybody. It'd been more fun if it was -5 plus or minus 2. Okay, let's look at another example. Okay, actually, well, let's do this one first, and then we're going to discuss maxima and minima. Okay, so tell me the vertex. The axis of symmetry. The y-intercept. The x-intercept. Do we have a maxima or a minima? And then let's look at the graph. We know from looking at the equation, since this is in standard form, this is your y-intercept. So it's at the point 0.08. That was the easy one. Now, the next easy one is max or min. How do we know if it's a maximum? What does it have to look like? If it's a maximum, it's got to go down. Because if it's a maximum, it has to be down. If it's a minimum, it has to be up. Is there any way we can determine which one of these two graphs we have? The leading coefficient. Is it positive or negative? It's positive. If it's positive, it opens up. If it opens up, we have a minimum. If it opens down, then we have a maximum. So we know we have a minimum because it opens up. Very good. So let's label A, B, and C. What's A?
1. Oh, 1/2.
Very good. 1/2. Because, yeah, it's just whatever's in front of the X and below the X. What's B?
-4.
C. So the first thing we're going to calculate there is, let's find the vertex. So it's negative b over 2a, and then g of negative b over 2a. Negative b over 2a. B is -4, so it's negative of the -4 over 2a is 1/2. So negative and negative makes it a +4. The 2 times 1/2, the 2's cancel, so it's 1. So the x value is 4. That's the axis of symmetry. So on this line is our axis of symmetry. Now we plug that inside our equation. So g of 4 is 4 squared over 2 minus 4 times 4 plus 8. Four squared is 16 divided by 2. 4 times 4 is 16 plus 8. 16 divided by 2 is 8 minus 16 plus 8. 8 plus 8 is 16 minus 16 is 0. So that says our vertex is at 4, 0. Everybody okay with that? So we know we have a vertex at 4, 0. We have an y-intercept at 8. Do we have another value point? This is a vertex. So we went 4 left, up 8. So we go 4 to the right, and 8 up. We have another point there. And the only x-intercept we have is x equals 4. Since that's a vertex. Is it getting easier? I hope. Or still complex. What are these? Which one of these are most difficult to find?
Doing the vertex?
The vertex?
No, not really. To me, I think the Y intercept. I mean, the X intercept.
The x-intercept will be most difficult, right?
Yeah.
The vertex is once you find the axis of symmetry, plug it back in the equation and work it out. It's just a bunch of mathematics there. And x-intercept is the quadratic formula. It all depends on what the square root is. And yeah, is anything really difficult? No, it's one part maybe more time consuming. We'll do one more. F of x is equal to,
So the, just real quick.
yes,
So the minimum that was 4 or 0 equals 0.
the minimum is at 0, 4. The way what you would say it is the minimum is 4 at x equal, no, the minimum is 0 when x equals 4. Yeah, the minimum is 0. That's the lowest we can go is 0. It happens when x equals 4. So the min is 0 when at x equals 4. I'm glad you asked that. I totally forgot to put it that way. Negative 2x squared plus 10x minus 23 over 2. Okay, we know already what is the graph going to look like. Do we have a max or a min? A max because it opens down. We know the graph's going to be like this, so we're going to have a max because it's negative. X, y-intercept, x-intercept. Max min. And the graph. So the vertex, we have negative b over 2a, f of negative b over 2a. So x is negative b over 2a. B is 10, so it's negative 10 over a is negative. So 2 times negative 2. So it's negative 10 over negative 4. Negatives cancel. 10 over 4. 10 over 4 cancels, simplifies to 5 over 2. So that's my x value, which is my axis of symmetry. At the line x equals 5 over 2. Then we take that value, plug it inside our function, and work it out. So we have negative 2, 5 over 2 squared, plus 10 times 5 over 2 minus 23 over 2. 5 over 2 squared. So 5 squared over 2 squared. 5 squared is 25. 2 squared is 4. The 2 cancels with the 4. We have negative 25 over 2. Since the first one and the last one are over 2, leave the middle one as a fraction. So 10 times 5, so 10 over 1. 10 times 5 is 50. 1 times 2 is 2. Minus that. So we have 25 and 23 makes it negative 48 over 2 plus 50 over 2. 50 minus 48 is 2 over 2, which equals 1. That's the y value of my vertex. So my vertex is at 5 over 2, 1. Let's look what this looks like so far. My axis of symmetry is 5 over 2, which is 2 and 1/2. This is my axis of symmetry. My vertex is at 5 over 2, comma 1. We know we have a maximum because it's negative coefficient, so it opens down. The y-intercept is at negative 23 over 2, which makes it negative 2 goes into 23 11 times with 1 left over. So it's at negative 11 1/2. It's between negative 11 and negative 12. Since that's 2.5 to our left, if I go 2.5 to our right, I go down 11.5. I have another point for my symmetry. Now I gotta find the x-intercepts. Find the x-intercepts, I use the quadratic formula. Negative plus or minus square root of b squared minus 4ac. Where my a is -2, b is 10, and c is -23/2. -10 squared, 4 times -2, -23/2. Two times -2. Just plug each one of those in there and work it out. On the bottom, it's -4. 10 squared is 100. We have a negative times a negative times a negative makes it a negative. This 2 and that 2 cancel. We have 4 times 23 is 92. -10 plus or minus square root of 8 over -4. Again, 8 is made up of 2 times 2 times 2, since there's a pair of those. So it's 2 square root of 2. The negative and this negative cancel. Do this 10 plus or minus 2 radical 2 over 4. The top, I can factor out a 2. So take 2 out of that one, gives me 5. Take 2 out of there, it's gonna be radical 2. Cancel with the 4. So my x-intercepts are at 5 plus or minus square root of 2 over 2. Which is what this is telling me is at this one, it's 5 plus square root of 2 over 2. This one is 5 minus square root of 2 over 2. Those are my x-intercepts. It just takes practice. You have to practice doing those. On this, when we come back on Monday, we'll do some word problems. And then we'll finish up this section, and then we'll probably finish up the chapter on Monday.
It's not right now, it's too long.
Oh, yeah, I agree with you. It's super long right now, yes. Okay, part of it is